Okay, so let's talk about Cassini's grand finale, and we're going to talk about essentially the mission. Hey dude. Okay, cool. So what we're going to learn today is what the Cassini mission is, why it's important, and like what did we learn from it. And we'll get kind of going through a bunch of different photos from the Cassini mission. So what is the mission? So essentially, this is the first mission. It started like in 1982, so it was actually a long time ago since this was conceived. And it has the European Space Agency, the Italian Space Agency, and NASA all working together to launch this mission, which was the first of its kind back in the day. And it was a very important time because it was just after the Cold War, so not many countries were really looking to work together. So this was actually a really big move just from that perspective. The other part is, so the first of anything is also really important, considering that, first person to space, the first person on the moon. This is the first mission to orbit Saturn, which probably doesn't sound like a big deal right now, but moving forward as we have more space probes that go to the solar system and beyond, we'll definitely remember the first time we went to Saturn and we had something orbiting around it. This is literally billions of kilometers away, so this is very, very, very far. So part of the mission is not only to orbit Saturn, but to also land on Titan, which is a moon. Not a ton of people know that we've actually landed on a moon that was not within our own moon or Venus or Mars. And this is really, really probably one of the most complex things to do. And the best way I can describe this is if you think about flying a drone in front of you, not too bad. If you think about flying a drone and landing it in the parking lot while you're in the building, a little bit harder. Now think about flying a drone and having a 3-hour delay on your response and doing it perfectly in a place that is completely alien that you've never been to. Then that becomes a lot harder. So it gives you a little bit of an idea that these guys really put a lot of engineering and a lot of work on this. Okay, so this is the only moon with an atmosphere, which is really unique, and the only moon with surface liquid, which is a huge deal. There's no other planet or moon aside from Titan that has an atmosphere and an actual surface liquid. Most planets or moons are either it's an icy body, there's not really liquid, and we know that surface liquid is important because that means there's a chance of life. So for us, that's really big. I'm not going to go through everything in this. This is just essentially giving you an idea of all the things it was doing since 2004. It launched in '98, so it's been in space for quite a long time. And essentially, by each year, you can see the Titan flybys over here, and then you can see the Enceladus, which is the other moon, some of the icy satellites, and then also the seasons that it's been able to observe. So I think Saturn has a 27-year cycle, so that's how long it takes to go orbit around the sun. So we've seen about half of that, which is still pretty good. Okay, so why is this mission important? Why should we even care about that we're sending a probe to Saturn? Well, a lot of it is practicing is one big factor. That it's pretty amazing that this is their first time doing it, and they've knocked it out of the park. Not a lot of people know, but when the Russians tried to send landers to Mars multiple times, countless times, they were not able to be successful once. That was just Mars. And NASA and the combination of ESA and the Italian Space Agency were able to do it on the first time. So having a lot of practice setting out orbiters, knowing how to deal with space, the kind of problems engineering. The other part is learning about gaseous planets. So Jupiter, Saturn, Neptune, Uranus are all gaseous planets, and those have really interesting characteristics, they have a really complex magnetic field. They also have, Saturn has rings, and what's cool about that is that Saturn didn't just show up with rings. That's actually not from Saturn. Saturn, and that's part of the mystery is how did those rings form? Where did they come from? And also that those rings are not going to always be there. They're eventually going to escape into space, and Saturn won't have rings anymore. The other part is looking at the assortment of moons. Saturn has 60 odd moons. And also how planets form around the star, so we understand where do we come from, how do we get here, and how does this stuff all come about. And the last part is searching for life. So we have this idea that life is in a habitable zone. And now we're looking beyond the habitable zone and seeing, is it possible to have life beyond Mars, essentially. Cool. So now we're going to get to what did we learn from this. So we originally thought that, the habitable zone is essentially going to give us liquid water. It means it's just right that there's, we have the sample size of 1, which is Earth, which you see all this life flourishing. So that means most planets in this area will probably have life. So that's what we thought that we would assume. But what we found out was completely not true. So this is Enceladus. So Enceladus, it looks really big here and actually really beautiful because it has all these like crazy little like lines and valleys going on in here. It's pretty much an icy moon, but it's only really the size of the UK, so it's not very big. It's like 500 kilometers. But when they checked out Enceladus, we were actually able to look up close. They found something really interesting. They found that there is actually a possible way to look at life. And you guys probably can't tell from this photo or even this photo, but what they saw is this. So what do you guys see in this photo? What would you think is giving off the idea that there could be life here? Does anyone want to know what these things are? Anyone take a guess what these are?
Geysers.
Yeah. So these are actually geysers that my boy William Herschel, when he discovered Enceladus back in the day, he would have flipped his shit if he knew that these had geysers. So that basically tells us that there is essentially water within this icy moon, that it's liquid. There's something actually coming out of here. It's not just ice, and that means there's possible life in there, which NASA never, or even the rest of the agencies, would never have thought would have been useful. So this guy is fucking rocking it right now, and he is super stoked that there is life. You probably would never have guessed there could have been life beyond Mars even. And so just to give you an idea of what is kind of happening there, is there's essentially a 5-kilometer crust of ice, so that's a lot to get through. Then you have this ocean, essentially, is what is thought to be there. Then you have the kind of the hydrothermal kind of system working in the bottom, and that's where it's shooting out these kind of like geysers. And so part of that gave NASA an idea and the rest of the agencies that we should have a mission that essentially would fly by and essentially take a sample of these geysers when it happens, so they can test and see if there is organic life in there, what kind of organic life. And the reason, like, you might have heard, like, for the average person, they care more about the intelligent life and want to see things with arms and moving and eyes and all this. But for the scientists, they really care about organic life, because the biggest question in astronomy or astrobiology is DNA universal, or is DNA only unique to life on Earth? And so if DNA is not unique, and we look at its organic compounds and it's something else like RNA or some other different form, then that's really, really interesting. Then that means there's a whole different set of life forms, there's whole different processes that could happen, and that would lead to a whole other conversation. Cool. So the next part is Titan. So we thought Titan, when they looked at it, they basically did a Doppler mapping, which I don't know if you guys know what that means, but essentially it's when you shoot kind of a signal at the moon itself, it bounces back, and then you kind of get this map of what the place looks like, because Titan is very densely, has a dense atmosphere, and so it's really hard to see what's in there, and even if you took photos of it, you wouldn't see what's underneath it. So Doppler will essentially send the signal, hit the moon, come back at us. And so what they found is that they had this graph that went like this, and had like this. And so we saw these lot of jagged lines and kind of going up and kind of going down. And they said, oh, okay, it must be like an ocean in there, because water is only that kind of turbulent. And if it was ground, it should have been more smooth. And if it was a hill, it would have been more smooth. So they said there's probably an ocean underneath there. So they basically thought it was going to look like something like this, and that they're going to essentially, they built the lander so that it would float in water. But, of course, like all things in science, that wasn't the case. Hopefully this will play. Okay, so this is going to look at actual footage of it landing on Titan. And I'm going to kind of walk you through what's happening. And I'll have some little text here, of course. So it has a heat shield as well to obviously prevent, to kind of reduce the speed. So it comes in obviously really hot and really fast. And once we start the actual procedure, the video, you'll see something interesting. So now it's actually started. So this is actually the actual footage. So now it's actually reduced by 15-fold of speed just from the heat shield that's kind of been on right now. You start to see these like valleys over here, so then realize, wow, there's actually must have been like a rain system, or there's something that caused all these valleys to appear. And also the bright areas, which you will see a little bit later, is a reflection from the sun, which is interesting because we're actually facing the sun in this. And so as you kind of go down, they're noticing it's looking a lot more like Earth than they realized, that there's a lot more features that they thought they wouldn't expect to see on a world like this. And now I think the parachute has essentially been produced and essentially like executed, and that's when they started to have this slower descent. And what's really interesting about this is that they thought, so this is really far away obviously from the sun, so there's not a lot of heat happening here. So they thought it would be negative 200 degrees Celsius, it's going to be really cold. What they found entering is that it was negative 10 or negative 20 degrees. And then it changed to negative 100, and then went back down to negative 50. And so the temperature was very different as they were coming down. And now you see it actually landing on the surface. This is the actual surface of Titan. And what you see is icy rocks. And this whole planet or moon rather, is all hydrocarbons, which basically, an example of that is like oil or gas. So it's very much all that. And a lot of the stuff hasn't even been reproduced in the lab. So they've never actually had hydrocarbons in this kind of mixture. And this is kind of more of an animation of how it kind of landed, essentially. So they had no idea that there was actually going to be solid ground there. And so they landed just like that and couldn't really go anywhere. But it wasn't meant to survive more than like 30 minutes while it was there. So that ended Cassini's, Huygens at least, its 7-year journey. And it gave us all that footage, which was amazing, which we've never seen before in any other kind of moon. So Titan is interesting because it also gives us the stage of a moon where it kind of leads on to this origin of life on Earth. So they're seeing these valleys happen, they're seeing these lakes, they're seeing all kinds of things, and that is kind of how Earth started initially. We didn't have life to start with. It needed something to give the elements there to get it going. And this is more kind of talking a bit about seeing these valleys. This is all like from the reflection of the sun, which is interesting because it really brightens up and shows you how reflective a lot of the moon is. This is actually a carbon lake, so this is actually a sea. I think they said it's something around like 1,000 kilometers across. So it's a pretty big sea, and that is also really interesting. We've never seen a sea before on any other area except for Earth. So that's also been really fascinating. This is just kind of a comparison of like, step on the moon versus this to give you more perspective of what the sizes look like if you were to be there. Yeah, cool. So we're gonna go on to the storms of Saturn. So this is an interesting part of Saturn. Actually, one of my favorite parts, aside from Titan, is probably the storms. So the first storm that they captured was one that kind of came out of nowhere. I mean, it does happen every 30 years, but they've never been able to witness it this close. And this was a storm that you can kind of see in this top right, and this is in false color, so this is not how it actually kind of looks. And this storm is raging. Like, this is a pretty intense storm, and I think in the next, Jupiter got nothing on this one. And so basically this is what they found in 2010. It started like this. The storm appeared, and the storm kind of continued, and it actually made an entire loop around Saturn itself, which is really ridiculous. Like, that's an immense storm that's happening. And what's interesting about storms, so just to give you a very basic definition of like weather and storms, is basically the combination of like hot and cold temperatures and mixing together, and you essentially get cyclones and all these other kind of things. But with Saturn, this storm, you probably may ask, why didn't the storm happen all the time instead of every 30 years? Well, a lot of Saturn, the wet side of Saturn is like the top area or toposphere or whatever, and below it, like when you go further down into Saturn, whereas the more drier areas are actually separated quite distinctly. And so that prevents the storms from actually happening, from those actually ever combining, until over time they've touched enough that it starts causing a big storm. So Saturn's got really interesting features of how this kind of happens. So it's erupted 6 times since 1876. These storms are like the size of Earth. So you can imagine one that's the size of a planet just happening. Like, it'd be really hard to imagine. That's how big they are. And these white spots are just kind of moisture from the atmosphere. And this is about 10,000 kilometers wide, essentially going around the planet. And yeah, it took about 6 months for this to circle around Saturn completely, to actually make it all the way around. So that's kind of fascinating. So that storm was pretty cool, but there is a better storm that's a lot more badass. So this is the storm, which doesn't look like anything from this angle, but the most interesting part right away, where'd my clicker go? There it is that it's a hexagon. Whoever thought there'd be a hexagonal storm on Saturn? Like, that is complete bonkers. Like, that's something out of like science fiction that they had no idea. And what's even stranger is that, so this is the North Pole. On the South Pole, there is no storm. There is no hexagon, so it's not like it happens at the poles. There's a cyclone out on the South Pole, but it's nothing like this at all. Yo, crazy storm. So the sides are about 13,000, about close to 14,000 kilometers from each side of the hexagon, so obviously this thing is way more massive than Earth. And interestingly, over time it's changed its color from blue to gold, which is also really interesting. And like we mentioned before, the South Pole doesn't have any hexagon. The relative size, so that's kind of, I found this on Reddit, so somebody actually posted the size of Earth versus the actual hexagon itself, so you can tell Earth would just be gobbled up by that storm easily. It's pretty much nothing compared to Earth. So this is an infrared view of the storm, so you kind of get an idea of the different layers of the clouds that are happening in there. It's not been measured, but it's been estimated that it's been about 300 kilometer winds per hour, so that's pretty damn fast. That definitely makes Irma look like nothing, but I won't downplay that too much. But yeah, that's a really massive storm, like 3,500 kilometers wide. That's a really serious storm. So let's take a look at a little bit of video. So this is essentially, they took many photos and pretty much produced a GIF of this. And you can see there's other cyclones happening here. So there's many ones that kind of happen here, here, so all around. So there's actually a ton of different cyclones happening. And you can also see the outer edges also kind of creating sort of this other, also staying to that hexagonal shape. So that's one view. This other view kind of gives you a bit more detail on like the clouds themselves. And you can see it's a pretty furious storm that's happening in Saturn. So that's definitely one that I definitely like a lot. It's very fascinating, it's very unique, and we've never seen it on any other planet. Cool. So we also thought that Titan was kind of a luck of the draw that we were able to find something that could have life, that had liquid water. And there's probably not going to be too many other areas that we could have liquid water, but they found this little guy, Dione, which is an icy planet as well, or icy moon. Sorry, keep saying planet. And it's not that big either, really. I mean, it's still relative in size, but it's 2/3 water ice. And water ice probably sounds strange to you, but they say that because you can have like carbon ice, or you can have any other hydrogen. You can have like lots of different forms of ice. So they distinctly say water in this one. So this one's kind of fascinating. It's also very, very small. It's like not much bigger, like much smaller than our moon. And these are some photos they've taken of the actual surface itself. So very, very rocky and rough. A lot of craters. There's one area that's heavily cratered that actually has like 100-kilometer size craters, which is massive, which is insane. That's essentially like an entire city just done. So that's also really interesting. The other part is this photo. So you see some craters. You also see these like strange lines, these kind of fractures, and they kind of bisect a lot of these craters. And so they thought it could have been from like cryovolcanism. So basically ice volcanoes, which is kind of a cool concept, and those exist. And when we found out that they're actually just ice cliffs, and they were just kind of creating these like tectonic fractures in or on Dione. So that was also fascinating to find out that they weren't what they thought it was. Volcanism was actually not at all. It's just cliffs. So Dione actually has a 60-kilometer ocean beneath this crust. And it actually has a thin atmosphere. So at one point it actually had an atmosphere and escaped into space, so they're not sure why or how that happened. But there's a lot of questions that need to be answered about this one. But that's just another example of another place for possible life that's way beyond Mars. And we don't necessarily have to look at the habitable zones, essentially, what they took away from this. So Saturn's rings. So this is also... there are people that can probably talk about Saturn's rings and just have a whole presentation on this because they're really, really interesting, and there's some weird stuff that also goes on there. Can anyone point out where Earth is on this? It might be really, really tough to see because some of mine even look like dust.
Look center on the left.
It's a little blue one next to the red one down there.
Someone says this?
Yeah.
That? My hot or cold? Where was the other dot you guys were talking about?
Well, up.
Straight up.
This?
Yeah.
Nothing.
Okay. Yeah. That's Earth.
Oh, cute.
Done it. Found Holdo. Yeah, that's us. That's the photo they took, I believe, for NASA did a photo called where they wanted everyone to take a selfie with Saturn, and so this is what they did, and everyone essentially, tweeted on this. Anyways, so the rings, I'm not going to go through every single one. I mean, we'll talk about the learnings from it, but basically this is a diagram. They kind of talk about, where the D ring is, the C ring, the A and B ones are obviously ones you can see through a telescope. If you've never looked through a telescope, Saturn is by far the best one to look at. You can actually see the rings, you can actually see this color. It's really, really something beautiful to look at. So, and then these are obviously all the moons that are orbiting, the bigger major moons around Saturn. Cool. So, the rings themselves extend from 7,000 kilometers to 80,000, so they definitely get out there. And what's interesting is the thickness of them is razor thin. So, from meters to essentially 1 kilometer. If you compare that to Earth, or just kind of relative to Earth, it would be essentially like paper. It would be so thin. And a lot of it is made up of ice and rocks and dust, mostly ice, but the big question is, how were these rings formed? And that was kind of the big part of this mission, is to understand more about the rings. So we learned that the rings, there's basically an outer ring that gets created, thrown off from when material and meteorites get impacted on the moon, and essentially creates this larger, G ring. So we'll go back to. I can't go back to it. I can. Aw. You cool, dude? It's not gonna work. Cool. PowerPoint's awesome. Where's my clicker? Okay, so I'm gonna try this again. So the G ring, essentially this little thin one out here, and that's been caused by meteorite impacts to the moon, and it's just been out there essentially. It just kind of creates this ring around Saturn. And why rings are interesting is because it's a mini solar system. Like, this is how solar systems are also formed as well, with this ring pattern, except instead of rings you have planets, and gaseous planets as well. So it does teach us a lot about how solar systems are formed as well. So skip ahead. Yes, skip ahead that. Okay, cool. So we also learned that there's a moon that actually also influences the ring as well. So this is a moon called Prometheus, and I had to put that there. The Prometheus, the moon actually tugs on this ring and causes it to kind of clump together, or essentially shift its shape a little bit when it's near it. So that's another part that they've noticed, that how some of these rings are forming and where they are, the distance between them. There's a lot of little interesting factors happening there. We also learned that there's moonlets, and that's basically when there's enough material that clumps together, you get little moons. And that's kind of how with Earth or any other planets, essentially how we form. We start off these big giant rocks and gas and all these kind of things combine together, get smashed to pieces, and then what's left is stuff like Earth or Mars or Jupiter or Saturn. And so they've discovered a lot of these moonlets in Saturn's rings, which is also really cool. Cool. So the last piece, we made really good time, is Saturn's aurora. So the aurora itself, as we kind of looked at the storm, is really massive. This is much bigger than Earth. And this is something where they've only seen auroras on Jupiter, Saturn, and Earth. So this is actually really cool to see. This is done in infrared, so this is actually not obviously how it looks, but there's some really, really big kind of auroras there. So it's really kind of interesting to see that. Okay, so kind of understanding, kind of bringing this home. So the Cassini mission, why I'm even talking about this today is because the next like 20 hours, this little guy is going to crash into Saturn. And it's basically going to end its 2-decade mission. And with that, they're going to essentially turn on all its instruments and measure, things like what's in the atmosphere itself, temperature, magnetic field, pretty much get as much science as it possibly can, and send it back to us before it plummets to its death. So the main 3 agencies, like we mentioned, the ESA, Italian Space Agency, and NASA, we had 19 countries contributing to the hardware and like 26 countries for the investigation side of it. So it's definitely like a world affair for this one little guy. It's a multi-billion-dollar satellite or orbiter, but it's given us a ton of different images. And I guess why it's kind of sad that it's going away, it's just a machine essentially, is because you'll stop getting photos like this, like Saturn or Titan, or look at any other, because there's no other mission going there now. Like that's it for now. Like we don't have anything on the way there. The last one before this was Voyager in like 1979, and so the next one is to Jupiter for Europa, and we'll use a lot of the same learnings we did with the Cassini. So for example, they used Titan as a gravity assist. So instead of using fuel to propel somewhere, they essentially use gravity to pull them or push them wherever they were trying to go to save on fuel. And they learned a lot of new tricks on the way because they had a lot of different problems that they deal with. And that's something you give a lot of credit to the engineers for, because if someone said to you, build me something that's going to survive the vacuum of space, it's got to travel billions of kilometers, it's got all the instruments have got to work when you want it to work, you can't send any help out there when something goes wrong, it's got to be self-sufficient, and it's got to last at least the 7-year journey. So 7 years without you ever touching it, and it has to survive and get there. And there were times before it got there where it wasn't waking up. Like they thought like it was going to be a dud when it got there, and finally it came alive. So they learned a lot from this, and it does teach us a lot about, even on Earth, what like weather patterns and how things form. So this is kind of what they call the grand finale. This is kind of the big thing with Cassini. This is kind of the dates of when it's happening. So it's basically, I believe tomorrow. Yeah, so tomorrow in the morning, before you guys even get up for work, it'll have already plummeted to its death. It'll have already transmitted all its data, which will happen, I guess, later today in the afternoon. And essentially, we'll have the last few images of it, and we'll get some last data from this, and that'll kind of be the end of Cassini. You can, there's an app called Eyes on the Solar System, and you can actually see this in action, quote unquote, where it's pretty much an animation, but it's done exactly to what's happening in space. It's been updated exactly to where the coordinates are. It's a really, really good app, and it has a really good, you can like poke around in Saturn, see the actual size of it, look at the moons. So you can also look at that and experience it with that. Before I kind of finish, I know I kind of rushed through a lot of this, because I was kind of conscious about time. Was there any kind of questions or anything that came up during some of this stuff on Saturn mission?
Why is it ending now?
Why is it ending now? Because it has very minimal amount of fuel left, and they could continue and just let it orbit around more, but because this is, they're getting closer to Saturn, so they can actually take, you know, material from its atmosphere and test it out, and it's completed its mission like tenfold, so it's done everything it's supposed to do. So that's why they're kind of ending it now. They want to give one last hurrah. Yeah, good question.
What's the distance between Saturn and Moon?
I don't know that offhand, to be honest. I don't know offhand. I wouldn't want to say anything to jeopardize what I think it might be. But I can get back to you on that. So it's been about, I think, about half an hour. So if we were traveling at the speed of light for half an hour, and we're heading towards Saturn, how far and imagine all the planets are just in a line, so like Earth, Mars, all the way to Saturn. Where do you think we are so far? If we travel half an hour at the speed of light, which is 300 kilometers per second. The moon is 300,000 kilometers, so you would have been there like in the first second. Any other guesses? I guess there's nervous, like I don't want to say the wrong thing. Okay, so it takes, that's the other way. You're thinking, yeah. So an AU, I don't know if you guys know what an AU is, but it basically is the distance from Earth to the Sun, which is about 144 million kilometers. The amount of time it takes light to reach here is about 8 minutes. Okay, so it's 1 AU. From here to Mars is about half an AU. So it'd take you 4 minutes to get to Mars by traveling the speed of light. If you go to Jupiter, which is about 5 AU, then you're looking somewhere like 40 minutes. So that's for pretty much just, not even at Jupiter. But if you're traveling the speed of light for about half an hour, you've just maybe got to Jupiter. So to give you an idea of like scale, things are really, really far. Like we haven't even left our backyard, and we're not even at Jupiter, and you're traveling at like the maximum speed you can go in the universe, which is the speed of light. It took us about 7 years to get there from our technology, which still isn't bad, but it takes a very long time to get there. Cool. Well, if there's any other questions, you can take them. Yeah. Right. How do we know? So over time, even like our moon, like is technically drifting from Earth. So even the moon will even get far away from us. And over time, things eventually kind of slow down because part of it is like the gravity, other part is like the spin, and the spin eventually kind of slows down over time. It doesn't continually be the same, even though it's a vacuum in space. There still is stuff in space, so it does have some friction, but essentially it just kind of gets wider and wider and just kind of drifts off. Eventually just space just kind of takes over once it loses its kind of momentum from the spin of Saturn. But so eventually, in a long, long time from now, we'll be there.
How long does that hexagonal storm last?
I don't know, like that thing.
I think you said it was about 6 months or something.
It took 6 months to go around it. I can't remember how many years that particular one takes. The hexagon, I'm not sure if it's how long it's been there for, because it was something new because we just saw it. Like we've never seen it before because we've only been on Earth and we've never been able to witness it up close. But so I'm not sure how long that one would last. But usually these things last for a while.
What's the theories around why it's a hexagonal shape?
I think a lot of it's to do is with pressure around Saturn. So a lot of the pressure on Earth with storms is not as intense as it is on Saturn, and so a lot of it, because of this pressure around it, is creating these like really interesting hexagonal sides, which only happens on Saturn. But the other part is, why don't we see them on like planets like Jupiter? And that's why it kind of raises a lot more questions. So there's definitely a lot more to the story than just pressure. And so that's why that's something we'd love to like learn more about, but they probably can't now because there's nothing else orbiting Saturn except for Cassini. But that's definitely an interesting storm.
How can they make inferences about the general land consistency when they bring the satellites down and eventually crash them or purposely land them on the planet? We're only seeing a very small area. Like if we were to land something on Earth, as an example,
Yeah.
and it happens to land in the sea.
Mm-hmm.
But to your to as far as the eye can see, all you can see is water.
Right.
You might make a mistake in assuming that it's all water.
Mm-hmm.
Until you like line and see sand or whatever.
Yeah.
But yeah, like how do they know what the whole planet's made up of by just landing in one place?
Yeah, so basically they use a lot of different wavelengths. So like infrared, for example, tells you a lot about a planet that you can't see with visible light. So the things you're talking about are probably more like what we could see in the visible spectrum, but they look at like X-rays, infrared, and that tells them a lot of different stuff. Even the Doppler mapping, for example, told them what the ground was going to like eventually look like. It wasn't 100% perfect, but it does give them a direction of like what it could look like. And they've used a lot of these ways, the way to inference this from like other stuff like Venus, for example, which was also one planet that we couldn't ever see behind the clouds because it's so reflective, and nobody knew what was on Venus until we actually landed on Venus and we found out it was a hellfire, essentially raining battery acid. Um, Literally, it was like battery acid. And so they kind of use a lot of techniques from stuff like that, but usually it's just to have a various amounts of instruments to tell them parts of them, and then they kind of put the puzzle together. But it's not perfect as you imagine. Like they just get little pieces, and then they try and do their best to deduce what the story is telling them.
What's which planets haven't we actually landed or sent anything to?
Uranus, Neptune are the two ones we've never. So we've flown by them from Voyager, has actually taken photos of them, and that was back in like late 70s, early 80s. But we've landed on pretty much, or we've seen Mercury up close. We've obviously seen Mars way more than it's probably the most heavily populated robotic planet that we have. Um, Jupiter, we've always seen we have something on the way there. Actually, we have something there right now called Juno that's orbiting it right now. Uh, and Saturn, we've seen the Neptune, Uranus. We haven't seen Pluto. We've actually seen not a planet, but still, we've sent something out there to take photos of Pluto. So yeah, it's really those two, Uranus and Neptune.
Is anything past Pluto's point, or is it different?
Nothing. There's a lot of like asteroids out there, and it's an a lot of ice out there. So there's a theory. I'm not sure if it's been confirmed quite yet, but there's a huge planet that's the size of somewhere be kind of like half the size of Jupiter. That's way out there. That has a very long orbit, but it's way out there. So going back to the AU, Jupiter I think is something around 40 AU, so it's 40 times further from the sun to the Earth. This thing was at like 80 AU. It was really out there. Like it's definitely like no man's land. But yeah, so I think the New Horizons, which did see Pluto, is heading towards a direction. I don't know if it's to that planet exactly, but it's heading towards another major asteroid or dwarf planet that they think is out there. So we'll see what comes of that when the time comes. Yeah, cool. Go for it. Yeah.
Why do they pick a particular location that they put to have the satellite land on the planet?
Right.
For example, they could choose that they're going to be landing on the planet to put it straight into the eye of
Oh.
satellite store.
Right.
Try to see like what on earth is happening down there.
Right.
But they're obviously choosing not to do that.
Yeah.
They pick some other location. So like, what do they use to pick the locations around?
Right. So, 100% honestly, like I don't know I didn't read up on like exactly why, but I mean, knowing about the orbits around Saturn, I don't think that so they can't change it enough so that it can go over it. Actually, like even Jupiter, we had never seen the North or South Pole ever, and so it's actually really hard to get up there and also try and aim for it. The other part is they're going through. You can't really see it very well in this, but they're actually going through. Once you get close to the rings, there's a lot of asteroids, a lot of like rocks. So they actually have to avoid a lot of stuff there. It probably would make sense, that in theory it might be easier to go directly onto the North Pole and see what's in that center of that eye. But I think depending on how the orbit is already going in, they can only pick one way really to aim for it, and it's really on one of the sides of it, as is pretty much how it was orbiting mostly.
Wouldn't it be risky to go right into the storm? Or we can't even really get something in the center of a storm
We
now.
wouldn't get data anyway. The data's already been sent.
Right. Yeah. So I think it's
Crashing there wouldn't actually see it.
of the storm. Or yeah. I mean, yeah, technically you wouldn't really see a ton. You're still going to get some, like, I mean, obviously when it's crashed through, you're not going to get anything then. But as it's approaching, it's still going to send some stuff back in terms of like the other instruments, because we have like last image taken, but where's my cursor, man? There it is. But as you kind of get closer and closer and closer, it's going to send as much as it possibly can through the deep space network. So essentially it sends it there. Then that machine or that satellite sends it back to kind of to Earth, or actually the deep space network's on Earth. So it sends it to them, and by the time it's already been done, it'll take about, I think, 3 hours or so to get to Earth. So yeah, I mean, it's still a good question. I don't know 100% why they didn't go for it, but that's my best guess. Is probably because the way it was already orbiting, that they couldn't change too much, since they don't have a lot of fuel, they don't have a lot of resources.
Maneuver to particularly.
Yeah, exactly. They're like, this is the best we can do with what we have. Exactly.
How many more missions do we have?
It depends on like what you're referring to. Like, so we have the biggest one that's coming up is the James Webb Space Telescope, which will replace Hubble. That's just one going above Earth. That one will probably be the most public-facing one, because that's what gives you all the really nice images. We have Juno that's already there. There's nothing really hard set in NASA's book, which is kind of one area where we're just not sure what's happening, because Mars is kind of there, but it's not really solidified. So I don't have a lot of. Right now, it's more likely that SpaceX may get there, a private company would get there before NASA, just based on the fact of the budget they give NASA. It's not enough for them to even get to Mars. But yeah, right now, Juno, I mean, they want to send another one to Europa, which is in Jupiter. There's nothing else that I know of that's upcoming. They'll go to another planet or another. And that's part of it, is not enough interest in space today than there was in like the moon landing, when you could send Voyager, and Cassini had a great, because this mission happened like just after like our moon landings happened, and I say we, the U.S. So it was definitely like Cassini probably wouldn't have happened in today's time. Like that would be so expensive, and nobody would want to put all that money in there. But kind of see what happens, because privatized companies are kind of paving the way now. So we'll see what happens with them. Cool. Okay. Well, thanks guys. Thanks for joining this lunch and learn. Yes. Thank you. Thank you.